Jake here, creator of Animagraphs, and today we're going to look at the research that I found to create the Golden Gate Bridge project, and then we'll have a look into my 3D file and just see the interesting things that were different in this project or new things that I had to learn to get it done. So let's just dive right in. Like the Golden Gate Bridge project, this one had a write-up from the chief engineer to describe the project, which is awesome. With the projects I started the channel doing, like the F1 race car and those things, there was just nothing. So I had to find it all by digging through the internet, surfing through the back rooms of the internet to find this hidden information. But with these projects, they actually publish these detailed documents. So I'll just, plow through this document as I've done in other videos and stop where I find something interesting, I don't know why we have this perception, but I'm probably going to revisit this multiple times throughout this video. Someone made the perfect comment about it too. They said, "You've changed the way that I see the world." And I feel the same way, because I don't know why we think this, but with the newer technologies we have, we tend to see past generations as being simple in a way, or not as advanced. But if you look at this graph here, all these old documents from the 1920s, even earlier documents from like the 1800s I found, they'll have like graphs and charts of water flow underneath the whole design of a ship, and it looks like it's computer generated. So this is the kind of stuff that we've been doing for a long time, apparently. I just didn't know that. Like really advanced visuals that are so well planned out that they would have had to calculate this probably with rooms full of people and then compile all the data points of this chart. But this is just the traffic planning for the building of the bridge. But they were doing all this stuff. They were doing flows and diagrams of how the traffic was going to be affected by the building of this bridge. It's really cool. So there's a look at the pier. All these things I have from the PDF documents that I can find, and just from when I start reading, I usually have to dig up photos. So with these documents, I have folders and folders of images, and California has a couple of historical sites with images on them. And so what I have to do is, when I find a resource like that, instead of going point by point, like, oh, I'm looking for this bolt or I'm looking for that specific thing, I have to forget that and just hoover up, suck up any information I can find and download it, knowing that I'll need it later. So that's an interesting way to research, is just to take everything you can get, because you know how hard it's going to be when you're looking for a specific thing. And then I'll go through those folders later when I'm looking for that one bolt or that one wire that I can't find. So these are my folders full of images. And for the pier, let's see, I'm going to the piers, the South Pier. Oh, look at this. These are all historic photos. These diagrams aren't always accurate. Some of them are like optimistic sketches or just done by news agencies and stuff, but yeah, I think this one's not totally accurate because it has the caisson at the bottom of the pier, which that was the first plan revision. So, but it's really neat, really interesting to look at. Oh, there you go, the process for making those holes in the foundation. Yeah, the big ram. Steam-powered derricks. Everybody loves Derrick for his heavy lifting abilities. The Tremie pipe. One of the things I like to show in these behind-the-scenes videos is that even though my model uses a scaled-down illustration style, that's on purpose. With research, you don't want to show dust and dirt and all these cinematic level realism. But I want to show you that, for example, this pressurization chamber, which was part of the revised plans, right, for the pier building, it looks like the one in my video. Even though mine is simplified, it still looks right. So I like to show that what you see in my videos is taken right from these photos. I'm not making it up. I mean, sometimes I have to make things up here and there, but I do my best, to get really close So it's accurate. And I measure everything. So here's the guys down inside of that little, those chambers. The pressurization chamber. That's one of the explosives, I believe, dropping down the pipe. Yeah, inside the pier structure. This looks like the water's been pumped out, so this is the final revision plan. Yeah, because you got the pressurization chambers here. The traveler, look at that. So you can see the pre-cut holes. This isn't for the plungers, those would be to the side here. But you can see, as I said, there's pre-cut holes throughout the structure for passing tubes and just for their crazy plans, you know, to get this made. The prefabrication, that's so cool. There's your cellular structure, and it shows, they have diagrams showing how much they reduce and the layout of the cells as it reduces as the tower goes up. Yeah, so here's something I don't quite understand. You'll notice on my channel I don't go into engineering theory. The only way I can understand it is visually. Just look at this, like they are already getting into like trigonometry or something, geometry. This stuff, I know it's a language, like if you could read this, you'd read it just like a sentence, like, oh, this puts the stress on that and it pulls on that, no big deal. But see, that's how I would explain it. So I have to look at this stuff and kind of try to understand it, but more how I do that is just by reading through the documents, and I read what they say. I read what the engineers are saying about what's happening, and then when I build it and I see visually like how it has to work by like actually setting things on top of each other, and I'm like, oh, it's got to be this way, it has to be. And then I can correlate it, and then I can understand more of that stuff. Look at this. Look at this. This is nuts. What? Yeah, Williott diagram for bottom panel bracing. It's just like part of a panel. This whole bridge is all made through massive equations. Yeah. When I'm driving over a bridge like this, I'm like, oh yeah, they put up the signs to say construction is happening, and then 2 years later, there it is. I don't know why I didn't ever imagine that this is what's going on behind the scenes. And even with the earlier, like the Brooklyn Bridge was one of the first ones that Roebling built, you know? They were doing this stuff in the 1800s. Yeah. More of that. But I think it's awesome though. All that said, I think this stuff is amazing. I love this. Look at this cool diagram showing the stresses placed on the tower at different points in the struts. So here they start getting into more of the construction, I think. You can see in this photo, it looks like a derrick on top of the tower, and then the run up here for the spinning carriages and the adjustment blocks. See, that's all the stuff. Now when you watch a documentary that's black and white, you'll be able to name all this stuff. Here's the start of some of the Anchorage construction. There's a derrick here, a big old tower crane it looks like. Here's the retaining racks back here and some of the I-bars coming in. The keyed foundation blocks, see? You can see everything. Here are some of the preparations for the pier and lowering down the forms for the concrete. And the access trestle, the ill-fated access trestle. This might be the final one. You can see the ring on the pier top where the derricks go around erecting the blocks. Look at this. Shows the different plans and how far they got. That's how I got the information. We'll zoom in a little bit here. So the original plan with the fender on the outside and a space full of water. You know, the first revision, second revision. There we go, look at the Anchorage. This is how messy it actually is. I simplified it, but you can see the counterweights. You can't see that here. You can see one way down there. You can see the counterweights floating and in this center gap, and all the reels and wires and derricks and all the, you can see in this photo how the ramp is really tall because they had to move all this stuff with each shoe and I-bar pair, with each cable. So all of the scaffolds as the strand leg and the jacks and everything have to move every single time. So that's really cool. Here's another document that I used a lot. And this is like an illustrated, sort of simplified write-up that's much shorter than that other PDF. But this is really, really amazing. And I just love illustrations like this. So this person, back in the day, was doing something more like what I do. Trying to make this stuff palatable to the general public. And so I did get a lot of information from here, things that you just can't find anywhere else. Here's some of the details. You can see them in photos, but I did get a lot of the details for the excavation process for the south pier from this document. You can see the derrick on the barge, the lifting frame, the interesting, I can't remember what they call this thing at the end of the pier, but it's like, it's still powered by electric motors, I think. Here's where I got some more of the details. I mean, this looks exactly like my video, you know? And I'm assuming this artist took this from old photos that we either no longer have or that I couldn't find. So really valuable information. Here's the plates and the dowels and the tabs that come up that were pre-stressed for connecting to the tower. The steam-powered derricks going around. The grinding wheel, which I did find photos of this stuff. Look at this. I believe that I could not find photos of how they pre-stressed this, where the jacks were placed. I could not find any information on that. Very obscure. But it does show the frame down in the pier foundation and the tower frame above it. So that was really helpful. Here's more detail about how they hauled up the initial rope for those footbridges. And this is showing when they hauled the cable between the two towers to set up the first footbridge. The only time ship traffic was ever stopped in the entire construction process. This is a drawing of how that went. I didn't animate that because I avoid stuff like that. I don't want to do like reenactments. I don't ever do reenactments. So I try to be really efficient with what I'm showing, and I try to keep it to things that you and I cannot imagine, that you have to be shown. Oh yeah. The storm cable layout, this was super valuable to have. I couldn't find that anywhere else, but I modeled it just like this. And it says white lights, red lights, green lights, you know. I modeled it exactly like this little drawing here. And here's how this person explained spinning. And you get it in the end that it's loops, because he's like, you turn it over and then you wrap the loop. But even that, like these drawings here this is how you're going to see spinning explained everywhere. Even in videos, it's really confusing. To me, it was super confusing. And I'm hoping that like my stab at it, that I was able to get it to where it's really clear, even though like knitting or anything tying knots, this stuff is really hard to visualize. But you can see the counterweight and the hauling rope and then the dead wire, the live wire, and everything is here. The throat, which is the name of that little bracket, the sleeve before the loop goes around the shoe. And he's just explaining some of the reason why they do it this way, the strand adjustment. This is called cold swaging. That's what this is called, when they join things together with the ridges and the special sleeve that's pressed over the wire. But, and you can see the little coupling down here. So this model of the shoes and the loops is actually really good. And this gets into something too that I only sort of am beginning to understand after the project, which again, I don't get into theory because I'm not an engineer. So if I got into theory, I'd get it wrong. I wouldn't know how to discuss the pressures and all this stuff. So I just model exactly what I see, and I take their word from the engineers. And so I'm like the intermediary. I report what they say. That's my job. But I will say that, like, thinking about this now, coupling the wire to itself like this and having loops around shoes that are then anchored seems to me to be really strong. That seems to me, just thinking about that, like, because otherwise what would you be like, poking the wires into a cement block and they just yank out? Like, this seems incredible to think of this and to build it this way. Roebling, that person and the company, they were building bridges for a long time. So that's sort of the genius behind it, plus other companies. But yeah, the guy's a genius. The other thing that happens in the modern world is that we don't always know all of the geniuses that are doing this stuff, but they spent their whole life doing it. It was their life's work, and it shows. Like, when you look at this stuff after the fact, and I didn't know. So now when I'm looking at this, making these projects, my mind is blown. I'm like, this is a Stradivarius violin. You know, we know that name. We don't know this name. This is just as amazing. In every way, it's that amazing. Every piece of this stuff is amazing. So we're walking around surrounded by Swiss watches everywhere. You know, even like the freeway overpasses become that, and we just don't know. Here's the setback for the saddle. That detail is so neat. The jacks, the bracing, the hexagonal pattern in the saddle. Look at this. This really helped me. This I found in photos too, but you can see the wheels and the where the dead wire lays in the strand saddle, the actual saddle. This shows a detail of the hauling ropes, the split sheaves, the split sheaves above the saddle that they can adjust, that are on rollers. I didn't call out those rollers in the video, but that's how they work. And this is a drawing of the Anchorage, and they're even more detailed than what I showed. There's a big derrick back behind the Anchorage I didn't model. The spinning saddles, which are down at that truss at the Anchorage, I did show this detail in the adjustment block underneath. Here's them switching loops, and early in the process, apparently they only had one wheel, and then they upped it to 3 wheels per carriages, 3 pulleys per carriages, but this is them switching. Some people had questions about how they switch those when it's so heavy, but when it's a single wire, it's not as heavy. And also, I didn't show this detail, but they have all the way down the walkway with the rollers, they have hooks. And in the old videos, which you can find on YouTube, like any old documentary, they show the guys like yanking the wires. They yank them down and put them underneath hooks as it goes down the walkway. And so, I don't know exactly, I couldn't get the information on exactly what it's like to be standing here switching these loops, but it's doable. You know, by hand, they would take them off of there and switch them. There's also clamps at the top of the tower. In some of the old documentaries, you see them clamping. They'll clamp down the wire at the saddle. And I kind of covered those details in the video. Here's another thing that I had a whole lot of fun dissecting, is they're showing the drive loops and the carriages. And so making sure I got this accurate was really hard, because again, anything like knitting or weaving is just so hard. So that's where I got they don't actually say in any document, not outright, maybe they do, but like it's buried, how many carriages and how many drive loops, and why would they turn around at the opposite tower. So I had to piece that together from many different sources, how this actually looks. So that's the drive carriages and their loops. And then you have this description again of the spinning process, but just look at this. This isn't necessarily mathematical equations, but it's still super confusing. Who's gonna like 1B, 4A? No, like I can't put this on YouTube, but I would tune that out. It can never be a lecture. Like, I make entertainment, and I'm fine with that. I serve a purpose in the world, right? But it can never actually be a lecture, because that is boring and it feels like work. What I'm serving up is the treat that would make you want to watch a lecture, and that's cool. Like it whets the palate, as they say. So then you want more, you know? That's what I subject myself to for 4 months, is thousands of lectures, taking years off my life. You know, the reward is worth it, but I can't subject you, the viewer, to lectures. That can't happen. This was really hard to find. Oh my gosh. This is the detail at the tower for the pins. Now, this other document, this other really official document, the official report, had drawings of all this stuff, but it's cut in half and it's buried, and it also has sections that are taken from that drawing, but as you can see, section F-F. This is the mechanism, the pins, and then I think these are the built-in braces that brace this cross piece right here. Finding photos of this was near impossible. All right, so we'll go to towers, I think. Tower top. No, it's actually under roadway. Sidewalk to tower. Tower connection right here. This is the best I could do. So I have the drawings, I have those sketches from that one dude, and then I'm trying to find it. So up in here, you know, you can see, I mean, you can start to see what's going on. So the roadway trusses end, and then there's some of that bracing you can see in the drawings. That'd be like right here. This is the side view. Here I'm trying to get a view, but they have the darn watermark right over what I need. So classic. But here's some of the roadway. I'm trying to find just the roadway at the tower. Here we go. See that pin? Finding a photo like this is so hard. It's so hard. I don't know why. Like, since it's Getty Images, and like when you search, it's buried in 1,000. That's why, like, when I find a resource, I just start downloading them, because I'm going to go through it later and find what I'm looking for. If you just go straight in to say, I want to see this pin right here, I want to see that little pin, you will never find it. You kind of have to come at it from the side. This one I had to mess. I think I have another one. Let's see. Yeah, I was messing with the brightness contrast because I need to see up in there, you know. This is one of those things where I get a little queasy to my stomach if I don't take breaks, because I really, really just... There's this strong push inside of me, this desire to solve the riddle, you know. All these wires telescope, by the way, because this thing moves a lot. When you're on the bridge, you might sense that something is moving, but again, as a know-nothing, which is me and the viewer, I would never suspect that this thing is like a space shuttle, you know, that it's that advanced. Let's have a look at some of the photos just while we're at it. So the Anchorage. And actually, these drawings I took these drawings from that main PDF, but I also had to go on Internet Archive and find the same book, because in this PDF, the main reports, as you can see, the pages are folded. Not the first time I've had that problem. They're folded when they were scanned, and a person scanning it would just be rifling through books from Google scanning operations 10 years ago. They're not going to unfold all these pages, but yeah, I feel like Indiana Jones or something, you know? Or Dan Brown or whoever. Like, the page is folded, how could you? I needed that, you know? Like, it's so aggravating, but who are you going to blame, right? So anyway, I found the same book on Internet Archive, and this scan of the book had the pages unfolded, but another hitch is that the pages are really lightweight material originally, so you can see the page behind it is ghosted in. And I don't know why, I must have edited this image for some reason, because it looks like it's mirrored. But so the page behind it is ghosted in. So again, it's hard to read, and it might be mirrored backwards sometimes, because I could be looking for detail that I can't find only on the page behind it and mirror it into here. Oh man, crazy. Yeah, so here's some of the Anchorage drawings. The suspender, the cable band, the shoe. I love to find actual blueprints. That is awesome. And I use them when I model it. So the anchor block and all that stuff, the drawings. Here's another example of the drawings that I'm using, because it's the best version I can get, but, you know, ghosted in over the top of like tracing paper. The trusses, the arch coming over the top of Fort Point, the footbridges. This I took a Google Images thing just to get the outside of it, because some of these details I wanted to get right. The footbridges passing through the pylons, that's so cool, and the tie downs would be right here. And the storm cables beneath there, you can see, look at that, lots of detail here. The inside of this building coming together with a bunch of piers. I didn't show all of the structure of the Anchorage inside. Here's a side view of the finished, painted Anchorage inside of the building. Wouldn't it be something to see that? Somebody in the comments said that they're one of the few people, besides engineers, who have gone inside of that building. I mean, it's got to be huge in there. Oh, man. More Anchorage stuff. The motorized reels down here, I modeled those how they look. The press machine right here, I think I must have used this photo for my reference. The long ladder that I modeled, the I-bars here, the derrick back there. Looks like another derrick on tracks. Here's someone standing. This looks like the anchoring for the footbridge. Yep, because they'd be going up to that truss up there, and this is the piece that anchors it at the back of the Anchorage. Here, the strand leg. Look how big it is. It's actually really big. Even the human scale in my video doesn't do it justice. But the strand leg and one of the I-bars they're working on, and someone just doing something at the strand leg. Look at this. The retaining rack. Look how huge it is. And they're here putting the I-bars into place and attaching them. It's all riveted together. A hook coming down from some lifting device, and the bedrock back here, which this has concrete all around it. This person standing here in the strands as they come back. And here's one of the spinning wheels, which I'll get to those in the other photos. So here's my collection of drawings for the tower. These were really hard to find, and again, some of these are from that other copy of the same book, but that was a better scan job. So even though you can still see the issues I was having there, here is from that main report PDF. It shows the staggering of, so these would be train car sized. Each one of these blocks is train car sized. And it shows the staggering of the sections on the interior of the tower and how they riveted them together. And here's again the tower cell sections at each different tier of the tower, so I definitely imported that into Blender. Here's the access doors, just a few examples of them. And these are ladders, I think. I'm not sure on that. But it shows the screened floor openings and then the ladders down here. So this whole thing is detailed, right? So they could make that book of how to navigate your way through there should you ever find yourself in the tower. More truss detail. And I didn't ever find a really accurate single version of the exterior of the tower. So here I was using software, like drawing software, to piece it together from the drawings I could get. Because it's not good enough to have someone's sketch. Like if I use that, it's going to be 5-10 feet off somewhere. So I have to have an actually, engineering accurate drawing. Because I just know that if I don't, something else I'm modeling is not going to fit. Case in point. So this early sketch from this was from some other book, This is not actually accurate, even though it looks great. You're like, oh, I could use that. Nope. It's still an artist's rendering. And here I have a photo of some of the embellishments, like the little exterior details. Wanted to make sure to get those right. The saddle. Yeah. Look at that. Just standing on top of the tower in a fog. Terrifying. The derrick lifting the saddle sections into place. Here's someone standing up on top of the tower. See, all these details, if you've seen the video, they make sense. They make enough sense, The grooves inside of the saddle. The machining of the saddle. Yeah, so they had to fix it down to a massive fixture table and then do the machining with this milling machine inside of there. Here is the count of the strands inside of the saddle. And this came also from some of the write-ups I was reading about why they oriented the strands the way they did, so I covered that in the video. There's again the saddle. And here's some specific photos that I was trying to get of the top of the towers. They actually had more outbuildings and stuff up there than what I modeled. But it just gets so detailed so fast that I can't possibly use all of it. You can see strands in the background, banded together. Spinning carriage. And again, some of the photos are really small and I couldn't find bigger versions. This is from a screenshot from a YouTube video showing the derrick when it's like attached to the truss at the top. Yeah, so the platforms up here, the working platforms. The spinning carriage approaching the top of the tower in that Roebling sign. That's cool. The outbuildings I didn't model. They make like a whole factory floor up at the top of the tower, basically. Because there's this lower platform, and then there's the footbridges. And I was even looking at how they get up to here. I could not find good images of how they get up there. They might use the service elevator, but if that wasn't operational, there's probably like staircases or ladders. Here I was trying to model the tie-downs. Great photo. That's quite a wrench, brother. Yeah, this is the tie-down details. The frame for the tie-down, even that's huge. Just massive. There you go. So the pylon surface here, and then the tie-downs. And the little, the places where the shims are put in, and the jacks go in this place here. So you get an idea of like the historical photos, but even the terrain, I wanted to show you like some of the stuff. I download actual 3D data for the terrain, but I use photos as well from any resource I can find to get an accurate lay of the land down in there. So when you see the terrain at the bottom of the ocean, underneath the ocean floor, all that's as accurate as I can make it. Obviously my models are simplified, but this is the actual texture that I prepared to drape over the top of my 3D model, how that works. Yeah. Some of this stuff I didn't use, but I still downloaded it because I want to make sure that I'm understanding the topography of this point in the Golden Gate. So just want to let you know like that even though in the video you might not, I'm going to use all of it, when I model it, I want to know this stuff for sure. So, really cool. I love this kind of stuff, the depth maps of the bay. There we go. So here's my Blender file. Oh, there it goes. Yeah, look at that. There it is. So as I've shown you before, like the references folder is where I bring in, let's make some of these visible. There you go. So there's an example of the sections I was trying to model, you know, at that point in the tower. I don't have that visible right now, but it's the tower cells. So even though I only showed the base in the video, I modeled the tower cells all the way to the top accurately. Because when I'm modeling this, I don't always know, as when I'm moving to director mode later on, I don't know what I'm going to want to use. So I just modeled the whole thing. As much like stuff that it seems like I would want. It's definitely like the process is like I'm multiple teams in one. So I'm thinking as the modeling team in this case. So I'm like, they might use it, you know. And then when I become the director, I'm like, oh, wow, I like that shot, you know, or I like this. And so since I have worked, you know, I spent time working at design studios and whatnot in my distant past, I remember what it was like to pass work between teams and all the stuff that you're thinking about when you have to work on a team. And when you get the project from some other team, like what they miss and the stuff they don't think about that you have to go back to them and request. And so I think about all that stuff when I'm doing this. Definitely thinking about what future Jake as the director is going to want to see. Yeah, so those are my reference images. I place all those in Blender. And this reference folder itself is just huge. So that's all the photos and drawings that you saw before. Let's look at the exterior. This is what I want to see. Yeah, so the top of it. If I hide everything except for that, there's the reference image in Blender. That's for the top. And the side placed, and then if I bring the bridge back. These reference images, sometimes it won't be exactly on because they have curvature based on the scanner they used, or if they were photographed, the lens of the camera will curve the image. So this I can use, but only so far, and then I have to default again to like the measurements that I've taken of how tall the tower actually is, how tall, how much this bends, all that stuff. But you can see my terrain and everything pretty much does fit the profile of this image because this is an accurate lay of the land as well. Of course, they surveyed all that stuff when they were looking at where to place the foundations and the anchorages. So yeah, I place all my reference photos in Blender, and I have tons of them in here, but it's cool because you can see them in the software as you build it. And I can turn them on and off. And one of the things that I used a ton on this project is something in Blender called geometry nodes. And so what that allows me to do in this case, it can do a lot of things. It's just like a really powerful way of using Blender, kind of adding to what Blender could already do. But in this case, like this road truss, like I don't want to be building this by hand ever. Like I would not have time for that. These are duplicated, you know, fabricated things. There's no way I'm going to be building this pixel by pixel. So what I did was I have a collection here, which is like a folder in Blender, and here's the roadway component. So if I hide everything, I build one instance of a thing, and that truck shouldn't be visible. There we go. So it's just this, let's zoom it in, just this. This is one instance of the roadway, right? And this is where my pixel perfect, you know, point by point build is. Even this has a modifier on it. It has a, let me bring that out. My Blender window is really squashed so that I can have it square just for the preview. When I'm making these, obviously it's, you know, I have a wide screen monitor and all that, so it looks a little squashed in here, even to me. But anyway, this has an array, right? So I just built the one truss, and I mirrored it side to side, and then I put this array on there, and that's what gives me 4 of them, right? There we go. So even then, I use all the tricks that Blender can give me to never duplicate work. And that means if something is inaccurate later on down the road, I can come in here and change one point, right? And it mirrors it side to side. And then this instance keeps all these objects intact as they are. When you come back and look at, let's look at just the roadway here. So the way that this road object is set up, so if I'm not in that instance, if I go back to the entire road, you know, this is the actual bridge model right here. And I go in there, all you're going to see is a couple of points just to align things. If I move those around, the whole thing moves. I think if I rotate them, there we go, look at that. So you can see, you know, you get the idea. That folder is made into like an instance of an object, and then, but what that allows me to do is like, these are on their own array, so I can like make the road build at that point. You know, just by running up the array. That also carries into the towers. Like the towers, the north tower is an instance of the south tower. So this is not, the north tower is not its own object. It's just a copy of the south tower folder. So if I make changes here, they also change there. So everything in this file, as much as I could do that, I'm using instances and modifiers and things like that, so that the actual piece that you see is going to be, see, like when I go to edit it, it shows the north tower because I'm just editing one and the changes are reflected through the whole project. Yeah, geometry nodes was really the hero of this project. So with these suspender cables, creating these bands, these are also, because you know they have to have the angle and the right amount of bolts and stuff per cable band, right? As you saw from the video. They're a similar kind of part, but the angle at each one of these is unique. If I go into edit mode in my software, all you see is a bunch of points. What these are doing is just saying, you can see that one cable band is kind of going crazy. These just align them, you know, along the roadway, the spacing between them. That's all these points are doing. Those points are on their own curve. So this cable curve, if I go in and move it at all, let's see if the solid view, there we go. So here's the curve, let's make it its own. So that's the curve, right? It's just an object in Blender where you can draw these like swoopy curves, right? But I've made so many things dependent on that if I move this curve at all, you can see it changes the whole bridge. If I change the curvature of this node right here, look at that, see? It has edited the suspender cables, it edits, I mean, so much stuff is connected to this. And that, again, is how I make it so that if I find that my stuff is inaccurate, at the end of a project, I can go in and actually make changes to it. Because you just, you know, you just could not understand, like there's so much stuff connected to this master curve that depends on the shape of that. And that actually, just to get nerdy, like that actually goes into the timing as well, because the way, when I animate the carriages going up the curves, if I make that point right there longer, then it will take that carriage longer to traverse the curve. So I will have messed up my animation. The timing won't be right. And the carriage won't get to the top of the tower when I thought it was if I change that curve right now. So that's how deep it gets when I'm making these, just the modeling and animation side of things. Again, just to illustrate that point of how I make everything modular. So going back to the bridge, the suspender cables, they are using Geometry nodes makes it so that instead of rotating all these and making all these by hand, it gets the rotation at that point in the curve, and it rotates the suspender, the cable band, this connector, the cylinder right there, and the sleeves. So you'll remember that, like, these sleeves, if I rotate this, it's gonna get crazy. There we go. So these little sleeves have to be rotated, the cable bands have to point straight down. So I think if we go into geometry nodes and look at the node tree, this is, it's ridiculous, but this is how I'm pulling in all the pieces that make one suspender cable, and I'm rotating them, you know. Suspender cable instance, that must be one of them, and I'm getting the cable band, I'm taking that curve, I guess. I don't even remember what I was doing. I'd have to, it's like anything code, right? Like you have to read through your own code and remember what you were doing. But this is the bolts to translate those bolts, and to make it so that, this is making it so that when the cable band, this makes a line of those bolts, right? Just makes a line of bolts. So this little part right here is saying, delete those bolts wherever this passes through. Otherwise, you'd have to build every single one of these one by one. But what I actually get is I have one instance of these, all these parts, and then I just have this row of dots to position them, and these dots conform to that master curve, and so everything, I can take it apart and put it back together really fast if I need to. So that's geometry nodes. I used that a ton in this project to duplicate things. Another place where that would be used a lot is in the anchorages, right? So the I-bars and all this stuff. If I go into, this is an instance, but if I find the instance, okay, let's go Anchorage components, there we go. And look at each individual thing. If I go into edit mode in Blender, you'd expect to see, you know, the points for all these I-bars, but you don't. All you see is one row of points because these, I used geometry nodes to take those I-bar objects and then angle them towards a point here. So I'm just never building that by hand. It's all done programmatically. One thing I really enjoy is making the environment again, so you can see where this depth images that I showed you before in my assets folder, that comes into play when I'm making the water, because this is all faked. There's no depth underneath this. It's just a perfectly flat plane, right? But then I use, you know, I just color it to make it look like it's deep. And it's just really satisfying. As an artist, I love doing this kind of stuff. Having the water be like lighter green near the shore, and having these little striations where it gets close to the shore, and the terrain would be right here. And then getting really deep blue. Just when you have the camera panning over the model and you see that kind of stuff and the reflections, and obviously I've shown in some of my other behind the scenes videos how I do make the textures flow through each other, so you get like the waves look really pleasing, you know. But the coloration of the deeper blue, that's really simple. That's just a texture placed right on this plane. It's not more complex than that. But the look of it, when you're watching the video, I think that it looks really pleasing, and it has a nice aesthetic. So as I've shown in other behind the scenes videos, I have this whole system that I added to Blender for fading things in and out, like entire folders of objects to fade them in and out. If I run up this slider here, you can see the road fades in, right? And it looks like it's being keyframed. I can lock that so it doesn't, there we go. But so that's how I fade things in and out, is I have this big window, and these are all the folders that correspond to Blender's folders on the side here of just all my objects. But I also have above that, this section right here, what's on the scene action or whatever, this is all of my the rigs that I have to build to move things. Here are the controls that I've set up. Like, I build all these things so that when I'm animating, you know, flying the camera around and all that, so that I can use this file as almost like a simulation or like a video game, kind of. So I just wanted to show you like the tower deflection. You know, if I roll this slider back and forth, it moves the tower, see? So I have control over all these little bits that I need to later on, you know, film, basically. So there's the tower deflection back and forth. And this is stuff that I get from the official documents, right? Like the measurements of how far that's supposed to deflect. Some of it I take artistic license. Like this is not actually an engineering simulation. I don't want to claim that. But, you know, the feet that it would move at the top and how much it can bend, I put those numbers in so that it's like a nice, pretty accurate visual. And then we have the hanging road deflection. So you can see, oh, there it is. Let me come over here. The hanging road right here. I can control how much that deflects back and forth. And as you can see, the way I've built the rig, the sidewalk also telescopes when you move the tower, or like when you move the tower, see the sidewalk telescopes? Watch that place right there. See, it telescopes, but if I move the hanging road, it also still works. It still telescopes. And that includes like the expansion joint, which you can't see because of all this junk in the way. I can fly in there in Blender. Let's see. Here we go. So I can fly. Look at it. Here we go. Look at that. Oh, we're high up. Okay. Yeah, the expansion joint. So if I do the hanging road deflection, you can see everything moves. I make them so that, again, when I'm switching teams as a one-man band, that future me who has switched now into animation guy, you know, that I don't have to think about how that should move. I can just roll up a slider, and then when I hear my own voice talking about it, I can decide how I want to visualize that with the camera angles and stuff. These are all the rigs. If I open that up, you can see there's just, I don't know, hundreds. Like, here's the barge pitching on the waves. That also makes it so that if I need to move an action like to a different point in the video, I can do that. Like, this makes it so that, you know, just like I was saying how I make the files so I can take them apart and put them back together again really fast. This is how I do that with animation, actually. Because this makes it so if I'm like, oh, the hanging road deflection, I want to change where that section is located, or I don't like how that looks, I can delete those keyframes, and instead of having animated all these objects in here and like having to hunt down into Blender and find where those things are animated, I can just come here to this one value, and this is where I can see, if I unhide that, I guess I can, yep, I can see all of the ways that one value changes throughout the frames. You know, we're at 90,000 frames here, which would be like an hour into the video. But I can see, if I hide all the other things for a minute, I can see everything that hanging road is doing. So I build these files so the animation kind of is all modular as well, and I can take it apart and put it back together really quickly and change when stuff happens. Yeah, so I think that's everything I wanted to say. I try not to plan these videos too much because I want this to feel kind of free and off the cuff. My main videos is where I do all my planning, so these I'm just going to discuss whatever comes to mind. So hopefully I covered everything that I wanted to get to, and maybe stuff that would interest you. And as always, I'm just so thankful to have everyone on the channel. And I'm really thankful to get to be able to do this and to share this with you, because if you feel that watching the video that you are glad this exists, I want you to know that I am also equally as glad to get to do it. So, you know, it's a really great relationship that we have. It's an interesting kind of relationship, but I'm thankful to be able to do it. So thanks for being here and for checking out my work and for enjoying what I do. Really glad to be doing this here with you.